So this problem, we're determining the voltages under DC conditions. Under DC conditions, a capacitor acts as an open circuit. So I'm going to redraw it as an open circuit wherever there's a capacitor.
Could you combine the circuit, the capacitors, and then redraw?
I don't want to do that because this particular problem is asking me for the voltage across each capacitor, and it will be easier to do them separately.
But could you if you want to? If it was
To come up with what the equivalent capacitance would be.
and then replace it?
It,
Is that a good idea or no?
What's the problem with that is in this circuit we have current flowing through part of it and not through the rest of it, and so our equivalent capacitance wouldn't help us much here. But the answer to your question is yes, we could. But it just wouldn't help us much with this problem. Okay, so what we have to look at is, now that we see that I've drawn my capacitors as open circuits, is there any place where current is flowing? And the answer is yes, there is current flowing. And that current is flowing through this loop right here. And that's going to be important. So I can see that no current is flowing through C1 and C2, and I can see that C1 and C2 are parallel. Even with these resistors, they're parallel because there's no current flowing. If there's no current flowing, those resistors aren't doing anything. So I can say V1 equals V2 because they're in parallel. The voltages are the same.
Well, only because there's no current and the resistors are.
That's right. So they're only in parallel because there's no current. If there was a current, they would not be in parallel because of those resistors. Now, if you look at the part I have highlighted here, that's just a single loop with 3 resistors in series. And so that has an equivalent resistance of 30 kiloohms. And so the current that's flowing through that loop is V over R. So 30 kiloohms, 15 volts over 30 kiloohms. As well, it's 0.5, but it's 0.5 milliamps. Okay, so if I make this ground, so if I mark ground here, then the voltage right here is 15 volts. As the current flows through this 5 ohm resistor, we're going to lose some voltage. And the voltage that we lose is 0.5 milliamps times 5 kiloohms, or the voltage is 2.5 volts. So as the current flows through this resistor right here, we go down 2.5 volts. So the voltage right here is 15 minus 2.5, or 12.5 volts. So now I can say the voltage right up here is 12.5 volts, and the voltage at the bottom down here is 0. So the voltage at the top of these capacitors, on the plus side of these capacitors, is 12.5, on the bottom is 0, so V1 equals V2 equals 12.5. . Now C3 here is parallel to this 15 kilo ohm resistor. So whatever the voltage drop is across this 15 kilo ohm resistor, that's the same as the voltage drop across capacitor 3. I can get the voltage drop across the 15 kilo ohm resistor because I know the current flowing through it. So V3 equals 15 kilo ohms times 0.5 milliamps, which is 7.5 volts. So there's a 7.5 volt drop across this 15 kilo ohm resistor, but that's in parallel with C3, so C3 also has to have a voltage of 7.5. Notice C3 is labeled with the plus on this side and the minus on this side, and that matches up with what we have here, so it is plus. Okay, this 10 kilo ohm resistor is in parallel with this capacitor right here, but I'm going to be a little bit lazy, I think, and rather than doing Ohm's law again on this 10 kilo ohm resistor, I know that I lost 2.5 volts here. I lost another 7.5 volts here, so I lost 10 volts here. So the rest is going to be here, which would be 5 volts. So I know that I've got a 5 volt drop right here, and that's in parallel with this one, so V4 has to be 5 volts, which is the same as what I would get if I did 10 kilo ohms times 0.5 milliamps.